Okay, now members, let's see an example when we have when we have a hemisphere. This is a sphere. If I'm to give you an idea of the sphere, this is a sphere. It's an orb. Those of you who watch Transformer, that orb there is what we call a sphere. Now, if you cut it into two equal parts, you create what we call a hemisphere. So this is a hemisphere. When you cut it into two, this is what we are creating there from that idea there. Okay. So a particle of mass 8 kilograms is just resting at the top of a hemisphere of radius or meters with its horizontal rim. Now this is the rim. That's what they call the rim. Resting on a smooth horizontal surface. If the surface of the hemisphere is smooth and the particle falls off the hemisphere at point B, show that the angle between the upward particle and CB is cos inverse of 2/3. Where C is the center of the hemisphere. So we have this as our center of the hemisphere. I'm going to call it C. So this is the upward vertical. So this is our upward vertical, like this. That's our upward vertical. So this is the point where the particle is resting. So this is where we have. It means that at this point here, the particle is having its initial velocity as 0. Why? Because it's resting. By telling us that the radius is 4 meters. So here we have 4 meters, here we have 4 meters. But the important thing is from here up here we have 4 meters also. There. The case there, even here is 4 meters, even here is 4 meters. But I don't want that. So far. Now, let us take this to be a point B, where the particle is going to fall off. Let that be our point B. Now this point B, this particle of course is going to be having its mass, causing the weight of the mass times D. Now, it means that now this is the angle they want. This is the line they want, CB. So the angle, we don't know it, let us call it theta. Now, of course, if this is vertical and this is vertical, it means that also this one is going to be theta. This angle, they are alternating. Now, because there is contact between this particle and then the hemisphere surface, we are going to be having what we call the resultant. That's our resultant there. Now, if you have resolved this, I think this is going to be our adjacent. This is going to be the opposite. So this is going to be our adjacent. So it will be having 8D cos theta. Then this is going to be the opposite. It is going to be having 8D sin theta, based on that angle there. If you have resolved this there. Okay. So that's the first case we have. Now here, we are going to be having a velocity v meters per second. So that's the velocity. So that is our particle here. Okay, this time. Now we always resolve towards the center because all the forces will be acting along towards the center of the circle. So this is, you see, a hemisphere is, by the way, when we put on the surface, it's going to be creating a semicircle, as you can see. So you always resolve towards the circle. Now you see that this idea, the particle is falling, you see it's falling, so meaning it's going towards what? Gravity. You see, it's pulling, it's going down. So it means that now, if I need to know this height here, the distance it covers at this point there, let me call this distance h. The distance it covers there, this point from here up there where it is before it falls off. So from there, I think we can able to see that we are going to resolve towards the center. Resolving towards the center. So you know that using the Newton's second law of motion, the resultant force is equal to the mass times acceleration. So our resultant force towards the center, we have 8D cos theta, then minus, we have the reaction opposing, equaling to the mass of the particle, which is 8 times acceleration. our acceleration of a particle in a circular path is going to be equally to that. Now, if the particle was inside, now the idea would be different. If the particle is inside, maybe like if this was here, the particle is here, then the action will be acting like this. But because it's here, that's why the action is acting in that order there. Anyway, so we have radius, so we get 8d cos theta minus r equaling 2. Okay, this is going to be 8b squared over r radius is 4. So we shall be getting 2, I think we see 2b squared. So now, can you get this squared in terms of u? Now, I'm going to pull out this here. So using a sector, consider I call this equation 1. Consider a sector, this sector here, let me pull it out there. So that is the sector I'm now going to consider. Okay. So this is the idea. So this is our center C. This is our B there. Of course, this radius from here up here is the same as from here up here because that's still the radius of our hemisphere. So you know that from here up down here we have 4 meters, up down there. This is our theta. Now I'm interested in getting this height here. This height I'm going to call h. Now why do I want to get h? I want to eliminate this u because there I don't have the final velocity, but I know the initial velocity is 0 because this particle is at rest. So you see that now, if I know this, remember this is 4 meters. That is 4 meters. From here up here is 4 meters. See if I break that, then it means that now I can get this. If this is adjusted, this is going to be now 4 cos theta. So from here up there down, it's going to be 4 meters. So meaning my h from there is going to be the 4 meters, then minus the 4 cos theta. As you can see it there. So that's the idea we are having there. So I have that. Now, from Newton's, from the third equation of motion, you see that now our S here, the distance we have covered from here up to here, because this equation works if you have linear motion. So the linear motion, you are going to consider this the distance we've covered from here up to here. But if you are in these things of circular motion, the distance covered is here. But in linear motion, we have covered this vertical distance. So our S is h. Then our A, the force that is accelerating this part is the acceleration due to gravity, which is going to be our A. So putting in here, so that I have now b squared equal to u squared plus 2dh. But we know that the acceleration in this u is 0. Anyway, let me first put it here. But u is 0 because the body, its initial velocity is 0 because it was at rest. So now there, I'm going to be having my b squared, okay, u squared plus 2dh. Let me put now. So my b squared is going to be 0 squared plus 2d. Now I have my h. My h is here as 4 minus 4 cos theta. So that one is going to give me, can I expand? B squared will be 8d, then minus 8d cos theta. So that's my b squared. So I call from 1, where is 1 here, where we had 8d cos theta minus r equaling to 2b squared. So we shall be having 8d cos theta minus r equaling to a2. Now r b squared, which is 8b minus 8b cos theta. Now what do we know? We know that at B, now the particle is going to fall off. Particle falls off. Particle falls off. What does it mean if it falls off? It means that there is no contact if it's off. So the reaction is going to be zero. This reaction, because there is no contact, it's going to fall off. So there will be no contact. And if there is no contact, there is no reaction. So that's the idea here. So now from here, we are having 8d cos theta minus 0 equaling 2. Can we multiply 16d minus 16d cos theta? So now I have 8d cos theta equaling 16d minus 16d cos theta. I think you see that our d is common and go out. So even 8 is common, 2 here, and I have 2 there. So b has vanished. So you have now cos theta equaling to 2 minus 2 cos theta. I bring this side. I have 3 cos theta equaling to 2. I think it's that my cos theta is equal to 2 over 3. So that the angle, the theta, so my theta is going to be cos inverse of 2 over 3. And that is the proof they want me to handle with ease. Okay, when I come to part B, where is part B? They're telling me find the speed at B. At B, where is our speed? Our speed at B is here. So let me call this from this one here, where I'm putting v squared equal to 8d minus 8d cos theta. We have this from here. So I have v squared equal to 8 times 9.8 minus 8 times 9.8 times 2 over 3. And so r b squared from there and simplify. What you do, you first press this on the calculator. Or you first press multiply this side and you have a uniform thing. So when I press multiply here, I'm going to be having inside again the LCM. This is 24 and 9.8 minus 16 times 9.8. It is going to give me 78.4 all over 3. And so my v is going to be the square root of 78.4 all over 3. And so rb is going to be, so I'm getting 5.1121 meters per second, and that's my velocity at B. So the particle is going to fall off with its velocity being 5.1121 meters per second. And the proof is done, and so the question. Don't forget to subscribe to the channel. List the apprentice, you'll find many things. I think by the members you can also change the quality of the video. You just go to, you click on those 3 dots on the video, then you go to that there is 360p, 480p, you click on it, you go to advanced setting, then you choose the quality you want. That's it. I wish you well.